Climate change affects forest ecosystems in manifold ways. Many regions experience a significant increase in forest damages due to changing weather conditions. For example, the increase of annual temperatures lead to more energy in the atmosphere, and this energy results in storms with higher wind speeds. Especially spruce stands are endangered by such events. Entire mountain slopes were deforested during the last major events. Atypical storms like tornadoes are on a rise in Austria as well, like here in Waldviertel, where such a storm uprooted and destroyed trees. A computer model which simulates storm events and their effects on forest ecosystems was developed at the University of Natural Resources and Life Sciences in Vienna. This is an example of a windthrow that we simulated with a forest development model. What we see here is a part of the forest landscape. Tree heights are color-coded. The warmer the colors, the taller the trees. We see an old-growth forest with very tall trees surrounded by few stands with lower height. The simulation shows how a strong storm event affects this forest. A strong wind throw can be observed in this old-growth stand, and the fallen trees spread further. At the end of the storm, a large area was damaged, and single trees in the surrounding area are impacted as well. This demonstrates that we are able to show processes on the computer that take place physically when a strong wind hits the forest. Finally, the computer model allows us to model and simulate effects of future wind regimes, including higher wind speeds on forests.
Mit Computermodellen abbilden und simulieren, welche Auswirkungen denn zukünftige Windereignisse auf den Wald haben können.
We can also calculate the influence of forest cultivation and selection of tree species with this computer simulation, taking future climate developments under consideration. Let's start with a scenario where Norway spruce is dominant. Here you can see the forest development on the landscape level over 200 years. On the right hand, we can see the volume of wood damaged by storm and beetles. For example, after simulating 100 years, we see a large wind throw. Overall, the course of forest development with this climate scenario throughout 200 years includes some major forest disturbance events. If we rather employ a strategy of mixed forests now, we can observe that the two scenarios are very similar in the beginning. Looking at the major storm events after about 100 years, the strategy of mixed forests already shows advantages. We will still have some damaged wood, but the volume of damaged wood is noticeably less than under the spruce strategy. From a silvicultural point of view, directly attackable surfaces in the direction of the wind should be avoided. In particular, this concerns avoiding sharp forest edges in the main wind direction. This results in a reduction of wind damages. Another important point: matured forests are especially vulnerable to storm due to their tree height. If there's a regeneration layer underneath, then the effects of a possible storm are smaller, because the next regeneration takes over immediately after the storm, and there is no long phase of bare ground, where the next population of trees has to establish itself first. If wind velocities are above 140–150 kilometers an hour, trees of a certain size, or forests of a certain age, are highly endangered, and forest management has very few options to prevent damages. But for storm events that we usually experience here in a 5 to 10 year cycle, silviculture can be very effective for developing and managing very stable stands by selecting certain tree species, optimizing spatial structures, avoiding edges, and also establishing stands in several vertical layers of forest stands. Global warming also increases other dangers for the forest. Higher temperatures favor a longer-lasting and faster development of forest pests. For Norway spruce, one of our major tree species, those are mainly bark beetles, such as the European spruce bark beetle or the six-toothed spruce bark beetle. The European spruce bark beetle survives temperatures below -20°C, which means that even cold winters don't result in population declines. Higher temperatures during growing season, on the other hand, speed up their growth. Starting at 8.3°C, their larvae development increases. At a temperature of 20°C, it takes 48 days from egg deposition to the hatching of the beetle, while at 25°C, it takes only 33 days. This is the reason why the European spruce bark beetle is able to produce several generations within a year, resulting in increasing infestation, especially for spruce stands that are weakened by storm and drought. Additionally, drought results in decreasing resin pressure, and thus also declining defense mechanisms towards bark beetles and other bark-breeding insects. Thus, weakened and susceptible host trees meet with faster developing bark beetle populations. In 2007, we had the storm Kirill, followed by the storms Paula and Emma in 2008. After these storm events, we had a massive bark beetle catastrophe in 2010. We tried to reduce these damages by practicing forest sanitary measures. That includes removal of tree from the forest as quickly as possible and debarking of damaged wood in the national park. We established bait trees, which means prior to the first flight period in March, healthy spruce trees were cut to attract bark beetles, which then bore into them. The reprocessing of such beetle traps is done after infestation, and the removal is carried out as quickly as possible. In order to control the population developments and the flight behavior of bark beetles, vermin traps, which attract the beetles with pheromones, are put up at several places. The bark beetle monitoring results can be found on the website of the Austrian Research Center for Forests, BFW. After major damaging events, the removal of the contaminated trunks takes a lot of time, but is critical for population development. Thus, research at the BFW aims at testing how the flight patterns of bark beetles can be influenced. The development of bark beetles, such as the European spruce bark beetle, is not only influenced by temperature, but also by precipitation. In this experimental approach, we investigate how different precipitation volumes affect the flight behavior of bark beetles. Here we see parts of logs that were infested by European spruce bark beetle under field conditions and now are being stored in cages. These logs are watered 3 times a day by this irrigation system with defined amounts of water. Every second day, we check how many beetles hatch from these logs. These results are compared with control logs, where no irrigation takes place. The experiment has also very practical implications and can be used for wood storage, for example. Other tree species are also endangered by forest insects. In France, for example, the pine Processionary moth has slowly spread north during the last decades. The main reason for the spread is increased winter temperature, because the caterpillars are active during winter and eat at daytime temperatures as low as 9°C. This pest has caused great harm in the pine forests of the Italian Alps as well. From here, it spreads north towards Austria due to rising temperatures. First nests have already been spotted on the Dobrach in Carinthia. Our native pines are also contaminated with a fungal disease. During Empress Maria Theresa's rule, large black pine forests were afforested in Steinfeld in Lower Austria. These forests are seriously endangered now. We have fungi on Scots pine and on the black pine, accounting substantially for the recent pine decline. And then we have bark beetles as well. Also weevil species can become dangerous. We also have jewel beetles, for example, representing their own family of insects, which can kill pines as well. From a forest protection perspective, it is important to pay attention to a diversity of tree species and forest structures. This promotes natural enemies and counterparts of forest pests, and makes it more difficult for specialized damaging organisms to spread. Longer drought periods and new precipitation patterns not only promote the development of forest-damaging organisms, but also increase the risk of forest fires.
Ja, wir stellen fest, dass wir einfach durch die Veränderung in Bezug
We're starting to realize that the probability of forest fires can rise, even in an alpine country like Austria, due to longer vegetation periods, changes in precipitation intensity, or longer-lasting drought periods in the summers.
Auch in einem Gebirgsland wie Österreich ansteigen kann. Was wir in den letzten Jahren sehr stark
In the last few years, we have observed many abnormalities compared to the past.
Vergleich zu den vergangenen Jahren feststellbar sind. Also man kann jetzt nicht mehr von einem typischen
It is not possible to talk about a typical forest fire course with spring and summer fires anymore. In addition to these two peaks typical for Austria, nowadays we have years with increasing fire intensity also during the fall. Or we do not have any spring fires due to higher precipitation in spring, and then a very strong summer period. Overall, it seems that anomalies and extremes are getting more and more the rule. The majority of forest fires are due to human activities. Only a few have natural causes. We know that about 85% of forest fires in Austria emerge due to human activities. Often it is the way a fire is handled, for example, throwing away cigarette butts or parking a car with a hot catalytic converter on dry grass. All these are possible reasons that can lead to forest fires. About 15% of fires have natural origins. In Austria, primarily lightning plays a major role. Whenever forest disturbances occur, it is important to reach the affected forest areas in due time with suitable vehicles. Whether the fire trucks need to reach the forest fire as fast as possible or forest workers need to reach storm damage or beetle-infested trees, a network of good forest roads is essential. Of course, fighting forest fires is a great challenge in a mountain country. In flat areas, it is possible for the fire trucks to drive on forest roads and to deliver their firefighting services right away. In a mountainous terrain, fires can spread very quickly, in particular up the hill, if the wind is blowing in a certain direction and if the area is very steep. In those cases, it can be very difficult for firefighters to extinguish the fires. Spital an der Drau in Carinthia was hit by big forest fires in 2015. About 65 hectares burned on this mountain. Out of that, 35 hectares were cultivated forest, that is, reforestation areas, and out of those 35, approximately 29 or 30 hectares were apt to be reforested. The rest was wasteland, rocks, etc. These areas vulnerable to erosion emerged, and thus we immediately initiated recultivation. Also, reforestation, of course, would be technically possible. The conditions are incredibly difficult at the moment, because we also face large browsing damages on forest vegetation due to high game density. Under these circumstances, reforestation is possible, but securing the culture from game browsing almost impossible. As this forest area has already been damaged by a large windthrow in the past, the protective forest function had to be improved with torrent control and avalanche barriers. In 2008, the big storm Paula deforested thousands of hectares in this area, including the sites where the forest fire occurred a few years later. This resulted in a stronger surface runoff and a higher risk for landslides. Thus, the Austrian Service for Torrent and Avalanche Control implemented technical control structures. The importance of such control structures can be seen in Großaaltal, which has been affected several times by flood debris accumulation.
Ja, es hat da am Abend vom 22. Juli
On July 22nd, there was a thunderstorm with very heavy rain, and around the stream Stilleckgraben it was getting very bad. The creek was as high as a house, which is visible by the way the creek bed looks now. There was debris, gravel and trees. We were lucky that the 3 objects located over there in the back were not more strongly affected. So property damage was minor, and thank God, nothing more happened. Such events show that the preservation and sustainable management of forests is required not only due to economic reasons. Moreover, all forest functions and ecological services need to be considered and maintained, in particular in light of the ongoing climate change.